Okay, so in this lesson, we are solving rational and polynomial inequalities. So the objective, of course, is to solve these inequalities by graphing and algebraically. Okay, so we're going to start with the graph, and this should kind of give you an idea of what exactly we're looking for. Okay, so if this is the graph, imagine if it's like f of x looks like this, and they want f of x to be less than 0. Because you have to think now, less than 0 means they want something that is under the x-axis. So you look here, the x-axis is here. If I want something less than 0, I'm looking at these areas. See, that part, the graph is under the x-axis. So I'm looking for what x values give me that. So the x, okay, for that area is between -2 and -1. So x is going to be larger than -2 and less than -1. See, it's x's that are here and here, between here and here, right? The other section of the graph is right there, where it's under the x-axis. So then x is between 3 and 5. So basically, that's my answer. I'm saying that x has to be between -2 and 1, or -1, and then between 3 and 5. Now, part B, they want f of x to be larger than or equal to 0. So I'm looking for the part that is above the x-axis, like that. Now, the answer for that part is going to be x is less than, because it's on the left side of -2, right? Everything less than -2, but also equal to, because they want equal to 0. So you got to go all the way up to -2. So it has to be equal to. Okay. The other section is this one. And your x value is going to be between what? -1 and 3, right? So there it is. X is larger than or equal to -1 and less than or equal to 3. And the last part is when x is bigger than -5. See right there? So x is larger than or equal to 5. So you put it all together and you get the answer. We'll try another graph. This is the rational graph, right? So again, f of x is less than 0. I'm looking for the section of the graph that is under the x-axis. So it's this area here, and my x, there you go. X is between -2 and 2. Okay, so that's it. There's no other section that is above, under the x-axis. So that's my answer. And I go to when f of x is larger than or equal to 0. So I'm looking at these two sections here on the left and on the right. Now it would be x is less than or equal to -2, right? Except that this is a rational function and this is an asymptote, right? This is the vertical asymptote. So the x, I mean, the graph does not really approach the asymptote, so you can't have equal to. So x has to be less than -2. Same thing here, x has to be larger than 2. Okay, you put that together and you have your answer. To solve these algebraically, it's pretty similar to what we just did. So here is an equation or an inequality, and you want to make sure that you have 0 on one side. So I'm going to subtract x on both sides. I have x to the 4th minus x greater than 0. And then what I'm going to do is I'm going to find all the zeros for it, which is the x-intercepts, right? Find the zeros. So I factor it out, and I factor some more. And remember, this is difference of cubes. You got to learn how to, or you got to review how to factor all this different types of stuff. But there's difference of cubes. So like by a formula, you get x minus 1, x squared plus, a, b, plus a, whatever. So that's a formula. And then I make them equal to 0 each. Right, each one equal to 0, and I solve. The first two, this one gives me x, this one gives me 1. Right? But this last one here is it doesn't give me real 0. First of all, it's not factorable, so I have to use the quadratic formula. And when I do the quadratic formula, I get complex 0. So unreal, imaginary, complex. So it doesn't matter in terms of the graph. So it doesn't appear in the graph. So that guy can go away. Remember, if you're graphing and you get complex numbers, that does not show up, right? Because we're graphing in the real plane, not a complex plane. So I get 0 and 1. And imagine if this is the graph, my x-intercepts will be at 0 and 1, right? And I split my graph into 3 sections, right? Because it's basically, if it's here it has to be the same sign. If it's positive, the whole thing will be positive, because if it crosses down to negative, you have an x-intercept, but it doesn't. So the only place it crosses is right here. So if it's positive here, it'll be all positive. If it's negative, it'll be all negative. So I split into this whole section all the same sign. This whole section here, all same sign. And this section over here, all the same sign. So I just test a number in each section, right? First of all, I'm going to test -1 for the green area. And that gives me a positive number, right? Because I put in -1 to the fourth minus -1. It gives me a positive number, so I know this whole area is positive. And I test a number in the between here, and I get negative. So this whole area is negative. And then I test this one. I test 2, and it gives me positive. And also, guys, you know polynomials, right? And then you know multiplicity of the zeros. If they're all multiplicity of 1, so it crosses through. So you know the sign has to change from positive to negative to positive. You know, because it doesn't bounce. If it bounces, then the sign stays the same. But if it bounces, the multiplicity has to be even. So if you're really good, you can think about that, and you don't have to do all the testing, right? But if you don't know that, you just test, and this testing works. So now I got positive here. Everything over here is above the x-axis. This is negative, so everything is below the x-axis. And positive here, so everything is above. If they want greater than 0, you want positive. So you want x to be less than 0 and x to be larger than 1. So you want the positive sections. So x less than 0 and x is larger than 1. And that's it. All right, let's do one for the rational ones. Rational ones, you have to find zeros, and you have to find the undefined ones. So basically the vertical asymptotes and holes. So again, I factor it out, and I do 0 for top and 0 for the bottom. So the zeros on top, I have x equals 1. At the bottom, it gives me the undefined values, like doing domain restrictions. So I get x is equal to 2, x equal to -2. And you use all 3 points, and you test all 3. So all 3 points here, and then you test each section. So I got that section in green, that section in red, that section in blue, and this section in orange. And then I test each of them, okay? And so I test this side, the green side. All right, so I test -3. I could have tested like 1,000, -1,000 if I want to, because this is everything to the left. But I test -3, and it gives me a negative answer. And then I test something in between here. 0 is the easiest one. I test 0, it gives me positive. And I test this one, 1.5 between 1 and 2, right? 1.5, it gives me negative. And then I forgot to test this one. Okay? No, okay, so I didn't touch that one because I know that all the zeros have multiplicity of 1, so the sign has to change. Okay, a 2 here is a vertical asymptote, and multiplicity of 1 means one side goes down, one side goes up. And this one's negative, so it goes down. This side has to go up. So this one has to be positive. And then if you want positive, okay, so that's how I know this one is positive. If you don't know that, if you can't think of multiplicity and stuff, and you want to test, you would have tested like 3 or 4 or 10, whatever, right? You would have gotten a positive number. So here, then, since they want greater than 0, I take the positive section. So it's between -2 and 1. See, x is between -2 and 1, and x has to be larger than 2.